Hi, everyone. This is our weekly announcement for, this is going to be for last week, which we covered chapter 1 last week. And in your weekly announcements, I will review concepts that it looks like you need a little bit of help with. I either get those from when I go to the Mastering A&P website, it'll show me which questions you guys, didn't do as well on. Also, and I didn't have a lot of people, in fact, I don't think anyone posted to the forum. And it's not a graded thing, but if you post your questions to the forum, I'll address them. Number one, I'll answer them in the forum, but I will address them each week when I do the weekly announcement. So for this week, the two things that I saw that we could go over were serous membranes. It looked like you weren't quite sure about serous membranes, so we're going to go over those first. And that's why I have this figure 1.11 pulled up from your e-text. And I was trying to see what page this is. I don't know how to tell quickly, but there must be an easy way. Anyway, it's section 1.6 in chapter 1. And the figure, again, is figure 1.11 or 1.11. And so we'll go over serous membranes, and then we need to go over negative feedback, homeostasis that's regulated by negative feedback, specifically when it comes to blood glucose and insulin. So anyway, let's talk about serous membranes first. There are 3 serous membranes in the body. There's the pericardium, the peritoneum, and the pleura, the pleural membranes. So the way they work is like, I'm trying to pull up the heart too. Hold on. Let's see. Move. There we go. All right, so if you think of your fist punching into a balloon, and your fist, which is it's a good analogy because your fist is about the size of your heart too. So when your fist punches into the balloon, there's part of the balloon that actually is touching your fist. And then there's air in between, and then there's the part of the balloon that's on the outside. So it's not actually 2 layers of membrane, it's 1 layer of membrane. But the way that it's organized is that part of that membrane is contacting the organ, in this case the heart, and then part of that membrane is on the outside, and then there'll be some fluid in between those two the 2 parts of the membrane that have formed. So it is a double layer, but it's a double layer that is produced by a single membrane. There's not 2 actual membranes that form the 2 layers. It's 1 membrane. Well, the layer that actually contacts the organs, in this case the heart, is going to be the visceral layer. So the visceral pericardium is the part that contacts the heart. It's this layer right here. And then you have, outside the visceral layer, you have the pericardial fluid. And then the part that lies against the heart wall is called the parietal pericardium. So the other serous membranes work the same way. It's just that instead of the heart, the pleura or the pleural membranes surround each lung. So the part that contacts the lung is called the visceral pleura. And then the part that's on the outside against the thoracic, the chest wall or the pleural cavity wall is the parietal pleura. And then for the abdominal cavity, the visceral peritoneum contacts the abdominal organs like your stomach and your liver and your intestines. All of those are surrounded by the visceral peritoneum, and then lying against the abdominal cavity wall is the parietal peritoneum. So that's how the serous membranes work. And now let me see if I can find an easy way to show you about glucose regulation and insulin. So we talked about that with homeostasis, that most conditions that need to be regulated, most homeostasis is regulated by negative feedback. So we're going to call this negative feedback of blood glucose. And we're really just going to talk about the stimulus here being, because remember, there's always, in all negative feedback, there's a stimulus. There is receptors that receive that stimulus. Then there's a control center that decides, that receives the information and then determines what to do with it. And it sends a signal to the effector, which negates or opposes the original stimulus. And we call that the response. So the response is to negate or oppose the original stimulus. So in this case, the stimulus is going to be in high blood glucose levels, or hyperglycemia. That's the condition called hyperglycemia. So this is not, I don't know if this is anything that was in your book or not. I'm just telling you because there was a question, and I on your that people got wrong a lot on their I can't think today. I'm so sorry. On your chapter 1 quiz. And so I wanted to explain it. The receptors and the control center are actually found in your pancreas. The receptors are, they're called G protein coupled receptors, and they are found on alpha and beta cells in your pancreas. And in this case, it would be the beta cells. So let's just do, since these are receptors that are detecting high blood glucose levels. So they're found on beta cells in the pancreas. Okay, so these receptors on the beta cells let the beta cells know that the blood glucose is high. And then the control center would actually be the beta cells. And what they do is they release insulin. And we're going to talk about the role of insulin in just a minute. We're going to talk about how would we describe insulin then. The insulin is sent to the effectors, which, among other things, can be liver cells. Okay, and what do the liver cells do? Their response is to carry out something called glycogenesis, which means that they are going to convert blood glucose into glycogen and store it. And that's going to lower, that means that we're going to have lower blood glucose levels, so that it negates or opposes the response. So what's the role of insulin then? Insulin is not the stimulus or the receptor or the control center or the effector or the response. Sorry. Insulin is actually the chemical messenger that acts on the liver cells to cause the lowering of blood glucose. So that's how you would refer to it. It's a chemical messenger, and it's actually a chemical messenger called a hormone that acts on the liver cells to cause them to lower blood glucose. So it's sort of an intermediate in this process. Okay, so now the next thing that I want to do is I want to go to our chapter 2, and we're in the wrong course. Oh my goodness. All right, let's go to our chapter 2 and make sure that you know what to do this week. All right, so chapter 2 is on chemistry, and you will be getting recorded lectures. I should be posting them today or tomorrow. But for the instruction on chemistry, make sure to read Chapter 2 in your e-text, view the Chapter 2 recorded lectures. I strongly encourage that you take notes and review the slides again on your own after you've done that. Now, the activities are to complete the Chapter 2 dynamic study modules in Mastering A&P, complete the chemistry lab in Mastering A&P, and then your assessment is the Chapter 2 quiz in Mastering A&P. So the graded activities are the lab and the quiz. These are the only two that get a grade. The other material is to help you learn the information that you need to learn for Chapter 2. The Chapter 2 slides are posted here, and please don't forget about the forum, the weekly forum. If you post questions, I will answer them within the forum so that everybody can see the answer, and also I may address those questions again in your weekly announcement. So I hope you guys have a great week. Please email me if you have any questions, or like I say, post to the forum. And let me know if you're struggling with anything. Let me know how I can help you. All right.